Often people talk about continuous integration. They say, like, this is something that I want to have available to me. I want to be able to use these tools in a continuously integrated way to build out my systems environment. Common cloud use case. And many people will say, well, I'm just going to look at my application and deploy my application out into some cloud solution, and that's going to be a large part of my continuous integration process. It's very powerful, and yet most people don't necessarily think about the entire operational complexity when they do that. They just think of an application. If they're looking at building a private cloud, or if you're looking at building a private cloud, or want to leverage some private resources along with public resources, it may be necessary to have your ops team start thinking about continuous integration as well. And so when I think about ops and continuous integration, I see a gap. People aren't really thinking about what it means to deploy your operational infrastructure, or at least the infrastructure middleware, so the software that runs your operations, in a continuously integratable, continually repeatable, and testable environment. So over the next couple of days, I'm going to be releasing some content that will look at each of the individual components of that. What can I do about modeling my storage in a consistent way? What can I do about modeling my network in a consistent way? How do I actually start modeling the compute infrastructure? What kinds of tools are available, and how might I do something like that? So this is hopefully going to be useful for people that are looking at the operations of their environment, not just thinking about it from the perspective of how do I get it installed, but how do I keep it installed? How do I keep it running? And that's where the continuous integration pipeline comes into play. So if you don't know anything at all about continuous integration and want to get a quick overview, we have a short class on continuous integration that looks just at the application development continuous integration model. This might be useful as well for those who are looking at application development or operations from an infrastructure management perspective. In other words, how do I continuously integrate these services? So hop on over to learn.kumul.us for that particular information. Continuous integration doesn't apply only to the application that you're running. It actually applies just as equally well to the infrastructure that you're doing. And implementing that is something that's often left to the user. I want to show you some tools and some of the capabilities that will make it easier for you to do this in your own environment. Well, we're looking at how the network can be applied to using a virtual environment for continuous integration, and specifically around continuous integration for infrastructure. Now, to me, there are two basic models where you would do this. One is in an all virtual environment, and one example of that would be a VirtualBox environment on a Mac, for example, in which case you'd have your physical machine, and that physical machine would somewhere have a network interface, and potentially multiple, but we'll just assume it has just one. And then within that machine, we're going to create a bunch of virtual networks. And our virtual machines will get spun up in here. And that might be a controller, that might be a network node, it might be a compute machine providing all the functions that we would expect in an OpenStack environment. The thing that has to happen, though, is that for these systems to work properly, and specifically if we then eventually are going to want to spin up a virtual machine here inside of a virtual machine, nested virtualization, to validate that our system works, there are a couple of different network components that we want. First off, we probably need to have an external router, which would end up in the network system itself. This is the network node. And we would want a network between the virtual router and the virtual machine that we want to spin up. And so we would create an internal tenant-side network, and that would probably be somehow tunneled between these two nodes. Now, likely for that tunneling to work, we're going to go over one of our networks that we build out, and so in reality, we would probably end up having that somehow route out across one of our networks, and then back into our machine and into probably an internal network in here for our virtual machine to attach to. There's probably actually another virtual network in here as well that the system would be using. The other thing that we need is we need public side view, public side connectivity. And in VirtualBox, the default is that one of those networks, we'll make this purple, one of those networks, this is the purple network now, is actually a NAT-only network. Basically, it's part of the default so that the virtual machines can connect with usually their zero-indexed network interface, so their little network card, and connect to that network. That network then goes through a NAT service of some nature to get to the physical interface, and that then gets off to our public internet at large. So this model is pretty common. All of our VMs would have access to that zero index interface. Virtual physical port here would be attached to this network in much the same way. Now that's great, but this network is not a normal network. There's no way for something on the controller, for example, to use that network to talk to something on the network node. So this network effectively becomes useless for most of our systems, although there's an expectation that somewhere that exists so that we can get this public-facing access. Now this is kind of unique to the VirtualBox environment, but it's something to be aware of if you're looking at VirtualBox as a possible management platform or virtualization platform for your environments. So now we still need to get our actual networks together. So we'll probably spin up a second network. In this case, I'll make this maybe this dark blue. So this network is going to be our management network and our public interfacing network. It's the network that we would use to actually log in from this machine. So if I opened up a terminal session here and I wanted to talk to these guys, I would do that through an IP address associated with this network. So let's make this the one, let's make it a 172.31x network, and we can make it a /16. We can make it huge. So that network's actually useful for multiple things. For one, I will create a second interface on all of my devices. Call it interface 1. I'll attach them to this physical network. And by doing that, now there's a path for this red communications to actually pass, right? So we can use it for that purpose. We would end up creating tunnels over top of that, but we have this management network available to us. So that's very powerful. This gives us a way to provide both management access and a tunneling interface for our other services. We could also attach a third interface, and that would be basically then the back-end interface. That's not always attached to the controller. Let's see, I guess we could use yellow. So again, we could create network interfaces on all three devices, but often this yellow network would only be attached, hop over these guys, to the compute nodes and the network node, because this is a back-end network. This is just for providing network connectivity for services. And there are potentially additional networks. Maybe people want storage networks and some other services networks, but for a basic, effectively core-based OpenStack environment, it's usually management network and then potentially a back-end network. The management network is also potentially the front-end API network. So if you want to control the environment through a command line interface or through an API, we'd be using that management network as well. So the purple network, not so useful. The blue and yellow networks are more to our style. So I'm going to go to the next page. I'm going to create another page here. And we'll look at this again now from the perspective of just an environment where I don't have to worry about that extra interface that VirtualBox creates. And so then I might have something like this. I'll still build out 3 pictures. Often these two get connected together, right? So the networking and compute nodes are the same, but we'll just assume that there's 3 separate machines at the moment. And then we'll create our, what do we have? We have a purple network, which is now our management network. And we'll create ourselves, we'll do a green network. And we'll make the green network our backend network. So even though I gave everybody an interface, I'm actually only going to connect these 2 nodes to the green network. And everything else is going to get connected to the purple network. So we have our purple network here. Purple network connected, right? And that's also where effectively our laptop terminal gets connected. And so this is going to be a 172 network. And this one here, the green network, let's just make that a 10 network. Because this network, we're going to actually basically use that as our backend communications network, and then virtually we have a router that we create internally here. We have a tenant network that lives over here, and actually has a segment that lives over here. And then we have an external network. This is the normal OpenStack services model. A VM that gets spun up, running out of colors, I guess we'll do red. So we spin up a VM. That VM, these are also VMs, right? But this virtual machine connects to this network. The network then gets tunneled across this green network, comes out of the tunnel and connects into the local version of that network. The router gets attached to that. And then there's this external network. In many cases, the external network would also be then tunneled to something else. You'd either have another network altogether, so potentially you'd have another physical network here, and some path out to the internet at large. And if you had a network environment where you had potentially VLANs available to you, or a VXLAN termination service where you could actually say this is the VXLAN that goes to the internet, you could do this mapping even into a virtual environment. In most CI environments, you're not necessarily trying to get the external world access to this environment. You want basically a test script running from here to be able to get access to the system. So being accessible through the management network is good enough. Now, the other thing to realize is that the management network also probably is in some way or shape or fashion attached to the internet. And it would be nice for these test virtual machines to potentially be able to get access to the internet. And so to do that, we might actually set up this kind of routing function, but rather than doing it in this particular fashion that we did here, let me see if I can get rid of this eraser. I don't want to clear the page, I just want to erase. So we get rid of this part of our router, and instead we go back to drawing and we say, look, we're going to create a little NAT interface here in this virtual machine, and NAT the address, the interface here, so that now I have actually a purple path. I have at least some way to get communication this way into the NAT through the router and into the rest of the world. Now, likely I still have this interface in here. So if I need to get to these addresses, so this might be, again, this might be a 172 as well, but maybe this is 21 instead of 31. Well, I can still get there, but then I have to have a terminal on this machine in order to get to that address space, because that would then be machine local. And being machine local is not a bad thing, but that means that if I want to use this emulated network segment to do anything with the rest of my environment, I basically have to create a VPN into this networking node, or this compute, basically shared controller node, in order to do all that. And that's actually pretty common, is to say, look, this is all one machine instead of two, especially for CI. Although if you're going to expand out, if you're going to use this as your router for the system, then potentially that router is a performance bottleneck. If you actually share it with the compute nodes, you might actually break that out for scale and performance purposes, assuming you're doing routing. If you're just doing layer 2 segment attachment to an external network, basically everything is a provider network in that case, then you wouldn't necessarily need this. So you see here we can get away with two interfaces, and actually this tunneling interface, there's actually no reason at all that I would need this extra network here. I could just tunnel right over the purple network, make my little tunnel instead of over here, and just say I'm going to tunnel off of this network instead. And I can get rid of this one. I'll just create my tunnel here. And now I'm tunneling over the purple network, just as effective in many cases. All right, so we can get rid of this guy. We can get rid of this a little bit. So now we have our tunnel going this way and our tunnel going this way, and the green network goes away. So I can get away with all of this on one network. The only thing is, how am I actually expanding my public interfaces and my public addresses? And if I don't need to expand them, so for a CI purpose, for example, as long as I can run any tests that I need to do on the network resource node, whether it's a separate virtual machine or is the controller, as some cases would be, depending on how much you collapse the environment, or create a VPN into that environment, then I can actually run those established sessions. Now there is a tool called shuttle that works for OS X and Linux. SHUTTLE. And shuttle is a great tool for actually creating this kind of a SSH-based VPN into this network node. For most of my use cases, especially for most of the CI class use cases, where I'm often running my CI environment from a Linux-based machine anyway, this is absolutely adequate. I don't have to create an OVPN or OpenVPN style connection in order just to expose this 172 network to wherever my tests are running from. Alternatively, instead of doing that, I could just SSH into that controller/network node and run my tests locally against that. That would be another way to approach the same kind of access credentials. And that's just because this interface, this little local network here that's being used as the outside of my router, will most likely have an interface in a namespace that's accessible to the network or control node, and that way I can run my tests there. So this is the way the networks are often set up. And the interesting thing is, let me grab one more page. We'll draw one more set of these machines. So this is my 2-node environment where I have a controller and a compute node, right? Controller plus net, and then my compute is here. And again, I'm going to have a physical interface of some nature, or physical-ish interface. What if it actually was a physical interface? Maybe this is on packet, the packet networking environment. Whether that's a single physical interface or a bonded interface doesn't really matter to me. All I'm looking at is the fact that externally I have, in the packet case is actually kind of interesting, because in the packet case, what I have is I have just a single network, and actually these guys come off to a router, and these segments are /31 IPv4 segments, which means that there really are only 2 addresses available. So there's you could have this be well, let's just pick some addresses. Let's make it 1.1, and this is 1.1.1.2. This guy here is 1.1.1.3 and 1.1.1.4. It turns out with Packet, you get 2 networks like this. You get a publicly accessible network, and then you get a 10-dot network that both have the same characteristic. The publicly accessible one has an actual route off to the internet at large, though. And that's nice. That means that if I NAT onto this 1.1.1 network, right, so I said I was going to probably have to create basically a little firewall rule in here to say from my, let's go back, let's not forget, we're going to create our OpenStack router, and it will have a local segment here for our OpenStack router, and that will go through here, NAT, and then present itself out onto the public internet. Now this is a one-way NAT, so this really is, better drawn sort of almost like a, I can only go in this direction with that NAT traffic. The responses will work fine, that's how NAT works, but only outbound traffic from here can actually get to the internet. I have no way, because I only have one address and I don't have multiple addresses, I have no way of getting back into that environment. That's okay. Again, for a test environment, I can now test on real hardware, which is what Packet basically provides me with. And again, I'm going to be tunneling either over this public network, or I could use the other interface, the private interface. Let's just go ahead and draw that in as one option, right? So we have our private interface. And again, we can attach that actually also a router. Make this clear. Right, so that's actually a router here. Again, same sort of thing. This would be 10.144.10. Actually, make U2. And this is .1 here. And this is .3, and so that means that this is 10.144.10. What is it? 4. Doesn't really matter. What really matters for us, though, is that we're going to create tunnels that come out of here for our tenant network. And that tenant network then is going to get attached to the router, and our tenant network then is going to get attached to any VMs that we spin up in this compute node. Nice thing about this is that this compute node can be a physical machine, so these can be non-nested VMs now, which means that if we want to also prove that our virtual machines are working at a reasonable performance level, this networking strategy can work for us. So this is the kind of model that people have to think about when they're looking at doing CI of infrastructure in somewhat restricted infrastructure. Now, if you can emulate the entire physical network model that you would have in your public or in your production environment in your CI environment, that's even better. But you can get away with at least implementing a virtualized network model that will still function, whether it be in a continuous integration environment or in the production environment. Now, perfect is absolutely to have equivalent environments across the board, but for infrastructure, often that's a little bit more difficult to implement. That does mean that you will want a staging environment at least to finally test the infrastructure with. But usually if you're working at an infrastructure level, that's not out of the question to have a way to validate that. And with that, you can actually now do continuous integration at the infrastructure level and map that out to the production environments as well.